Hello, welcome guys to my YouTube channel Prakash Coaching Classes. Today we are going to start a new science chapter which is electricity. So talking of when it comes to electricity, we all have known this term as it is often used in our day-to-day life. Today in today's world, it is unimaginable to think about electricity as it has various uses. आप कुछ भी करिए, इलेक्ट्रिसिटी के डे टू डे हमारी लाइफ में बहुत इम्पॉर्टेंट रोल है। कोई भी काम बिना इलेक्ट्रिसिटी के पॉसिबल ही नहीं है। नाउ विद एज वी डिस्कस इलेक्ट्रिसिटी, द फर्स्ट इम्पॉर्टेंट टर्म कम्स टू आवर माइंड इज करंट. Now what is current? The current is the rate of flow of electrons. Remember electrons, it is a subatomic particle in the atom. So here the definition of the scientific definition of the current is the amount of charge flowing through a particular area in a unit time. Indirectly, the definition of current can also be stated as the rate of flow of electrons. It is defined by the formula I equals to Q upon T, where Q is the charge and T is the time. The standard unit of SI unit of current is ampere, which is represented by symbol A. Second, electric circuit. Now what is an electric circuit? Electric circuit is a continuous and closed path of electric current. Electric current. Electric circuit. What is electric circuit? A continuous and closed path of electric current is called electric circuit. This means that the circuit has to be closed. Remember, electricity only flows when the circuit is closed. In open circuit, electricity does not flow. This is a diagram to represent the current, electricity. Here this symbol represents the V, voltage or battery. This is the bulb which we are using in our household. A is the ammeter, which is a current measuring device. Now the current always starts with the positive terminal of the battery and it moves in the clockwise direction as seen in this figure. Now an important point to be remembered is that if the current is flowing in the clockwise direction, the electrons will flow in the anti-clockwise direction. This is a sign convention which is taken in the case of electricity, that current and flow of electrons are both in the opposite direction. Next is electric potential and potential difference. So in this topic we are going to study what is electric potential and what is potential difference. So let's understand electric potential with the help of two copper plates. These are the two copper plates which I have used. Now consider this: charge only flows from one point to another when there is a difference. Means you can understand it by with the help of a pipe. इसको अपन ऐसे समझ सकते हैं कि एक नली पानी की नल में अपने लगा दी, पानी हाई प्रेशर से लो प्रेशर की तरफ दूसरा एंड से फ्लो कर रहा है. वाटर फ्लो तभी करेगा जब हम उसको एक प्रेशर, उसमें प्रेशर डिफरेंस क्रिएट करेंगे. सिमिलरली हियर ऑल्सो, whenever we use two plates, the two plates should have different potential, one at higher potential, one at lower potential, and there should be a difference of potential between these two plates. Suppose I take this plate as positive charged, this as negative charged. So whenever there is a difference in the potential, the charges will flow from this to this. Individual plate charges is known as electric potential, and the difference between these two plates, the difference of charges between these two plates is known as electric potential difference. Electric potential difference is very important and in which we have very much interest. So definition of the potential difference is work done to move a unit charge from one point to another, and its formula is V equals to work done upon charge. SI unit is volt, which is represented by W, and the device which is used to measure the potential difference in day-to-day life is known as voltmeter. Now in next topic is circuit diagram. In electricity, while describing it in theoretical, we day-to-day require certain symbols to use, such as voltmeter, resistance, electric bulb, in order to explain the electricity. How few of the electric symbols I have I'm trying to explain you, which are very important, which we will use in our numericals also. So let's go one by one. The first one is electric cell. This is a symbol of a cell, a positive terminal and a negative terminal. Second, plug, key or switch, open. This is the symbol of a switch, open. The switch is basically nothing but a switch which we are using to turn on and off of an appliances in our house. Second, plug, C, closed. Electric bulb. This is the same electric bulb which we are using in our house. Next is resistance. This is symbol of a resistance. Ammeter, symbol of ammeter. Voltmeter, this is symbol of voltmeter to measure the voltage. Next topic, Ohm's law. It is a very important topic of this chapter. Any board exam, one question of Ohm's law will definitely come. Either it will be theoretical or it will be a numerical. So this is a very, very important topic of this chapter. So what Ohm's law states: the potential difference V across the ends of a given metallic wire in an electric circuit is directly proportional to the current flowing through it, provided its temperature remains the same. Now let's understand what it's actually trying to say. Say you have any metallic wire and it is a closed circuit. The voltage which you apply to the circuit will be directly proportional to the current flowing through it, provided the temperature remains the same. At a given conditions, voltage is directly proportional to the current. This is what it's trying to say. Removing this proportionality sign, we get a constant which is known as, represented by symbol R. This is nothing but the resistance. Its name is resistance. SI unit of resistance is ohm and symbol is this. Again, if we plot a graph of voltage with respect to current, we give a straight line. So this is the theoretical meaning of the Ohm's law. Now next, factors affecting resistance. Let's understand the parameters or the factors which affects the resistance. Resistance is basically, you can say, the parameter which opposes the flow of the current. Okay, like you can say, you can take any appliances in our day-to-day life: fan, bulb, AC, geyser, laptop. Every appliances have a definite amount of resistance in it. Now let's take a look on the factors which affect the resistance. Resistance is directly proportional to the length of the conductor, L. Longer the length of the conductor, longer the resistance. Resistance is inversely proportional to the area of cross section. Let me draw a diagram of a conductor. This is length of the conductor. This is the area of cross section of the conductor. This is meant by A. A means area of cross section of the conductor. If we remove this, we will get R equals to rho L upon A, where rho is the constant and it is known as resistivity of the material of a conductor. It is the property by which the resistance is defined. I will take an example for this. Have you seen any example of an insulator? Take an example of like rubber, and take one conductor which is copper. Okay, the resistivity of rubber is very high. Because of that, it does not allow current to pass through it. And on the other hand, the resistivity of the conductor, say a copper wire, is very low. That's why it is allowing the resistance current to flow through it. So this is meaning by the resistance. Now let's take an example to understand Ohm's law, or numerical example. This will help you to understand better. Now let's take an example. The potential difference between two terminals of an electric heater is 60 volt when it draws a current of 4 ampere from the source. What is the current will the heater draw if the potential difference is increased to 180 volts? Now we are given here voltage equals to 60 volt and current equals to 4 ampere. Applying Ohm's law, V equals to IR, we will calculate the resistance. As we all know that the appliance is same, thus the resistance across the appliance will remain the same. It will not change. So applying that concept, when the potential difference is increased to 120 volt, the applying Ohm's law, and we will get the value of current is 8 ampere. So as you can see here, when the voltage is 60 volt, resistance is current is 4 ampere. When the voltage is increased to 120 volt, the current is also 8 ampere. When as you increase the voltage, as you double the voltage from 60 to 120, the current also get double. So this applies the Ohm's law. So thank you for watching this video. Do like, subscribe and share the video. Thank you.